Okay, here we go. So our original order, please, okay? Today is April the 21st, 2017. Okay, so we have f. So we go here, please, guys. So we have f of x is equal to 5x cubed plus x plus 1. Now, you will be asked to do this on the final exam. Okay, one like this. Okay, so I'll say use first principles. First principles is the limit definition for that. Okay, I'm going to ask for a random volunteer, and we're going to do Spider-Man today, so I want everyone to be involved in today's class. And that random volunteer is going to be James Campbell. What does f of x plus h mean, please? Sorry?
You mean like what he's doing?
Yeah. Yeah, good, okay. Good. One, two points already, this is great. Minus f of x is going to be the same thing, I'm just going to do this. Okay, hopefully this is all starting to come back. Right? I hope. Alistair, how do you cube something? What is the pattern for cubes? Okay. Okay. Now, going back to one of these notes, sorry, right? Was I made a typo? I saw it and I thought I let it slide, but nothing getting by you today, that's good. Now, going back to when we did these limit things at the beginning of the year, what's your cancel out, Emma, when we do our subtraction here? What's your cancel, if you remember back? Yeah. Very good, because remember, these things can't be divided by h, right? So they can't be divided by 0, so we're going to get those to cancel out. So I'm just going to expand this out a little bit. Extend the page, and hopefully that'll line up for me. Perfect. So I call that lim. H approaches 0, 5x cubed plus 15x squared h plus 15xh squared plus 5h cubed plus x plus h plus 1 minus 5x cubed minus x plus 1 all over h. Okay. This should hopefully, the happiness of these questions should be rolling back at you hopefully by now. Right? Haley, why am I happy? What cancels, please? Yeah. So I'm left with all right, we're feeling good about this question, or at least I am. I'm back in calculus mode. Vectors are done. Algebra, woohoo. Tanner, if you recall back from 6 months ago, what do we do at this stage in the game? Yeah, everything has an h in the numerator, right? Now, one thing that people forgot to do is, what is h divided by h? 1. A lot of people told me it's 0, okay? So just remember it's equal to 1, so that's not going to cancel. Therefore, this is going to equal limit h approaches 0, 15x squared plus 15xh plus 5h squared plus 1. We'll bring this down one more time. All right. Brendan, what is my very last task before I define the derivative? Yeah, sub h equals 0 in. So what that's going to do, it's going to cancel out those little middle terms. We'll be left with f prime of x equals 15x squared plus 1. Just as a quick little review, this will open up to anybody here, not necessarily Noah Sadler, who's up next. What does derivative mean? What did we do the derivative for? What does that give us? Go ahead.
It's the slope at any point on the graph.
Right on. It's the slope at any point on the graph. It's the slope of the tangent for any point on the graph is what it's going to be. Okay? Or the rate of change if we're going down that definition. Now, I'm going to show you today how that question can be done in one line today, okay, instead of 15. So please don't throw anything at me, okay, because if you remember your assignments, like every question took you this long to do. If I were to give you that assignment after today, you'd be able to do it all in one line each question, okay? So, but yeah, we'll get to more worstly things in this course, okay? But today will be a day of victory, is what today will be. Okay, any questions on this? You will be responsible for this under final exam. Something like this will have to do with the limit definition. I'm going to show you the regular definition of derivatives today. All right, here we go. Ready, set, go. All right. Today's lesson is called Derivative and Polynomial Functions. All right. We're going to say, remember, that a derivative is the instantaneous rate of change of a function. I'll get out of the way here. Today we're going to prove some basic derivative rules. And we're going to say that a derivative can be written as either f prime of x or dy by dx. What that means is a small change in y compared to a small change in x. Okay, and if you remember small change, I'm talking about just 0 plus is what I'm talking about. Okay? It's basically a very, very small amount. Okay? All right. We're going to do a few proofs here today to make sure we can get these to work. Once the proofs come out, we'll just do examples. This pain of the proofs will make your life a whole lot easier. You know what I'm talking about, right? What you just saw on the board was painful. That warm up, right? What you're going to show is going to be nice, right? You got some positivity. Yes, it's going to be beautiful, Mr. Sadler. It's going to be beautiful. Here we go. Example 1. Use first principles. To find the derivative of of x is equal to 5. Okay? Now, before we even solve this one, let's talk about what it means. Noah, back from grade 11, what is f of x the same as? Y. So the line y equals 5 looks like this. Noah, still with you, what's the slope of a horizontal line like this? 0. Okay, so the derivative of this should be 0 before we even do any work. But let's actually work it out to make sure, okay? So I'm going to say f prime of x equals limit h approaches 0, f of x plus h minus f of x all over h. Now this is the part that confuses some people, so I'm just going to slow down. If I sub in x plus h everywhere I see an x, what does 5 change into? Good. There's not, you can't get anything by you, right? X's doesn't switch, right? There's no value, no matter what the x value is, the value is going to be 5. So this is equal to 5. Great. If I sub in x for x, what's the answer going to be? F of x is going to equal 5. Good. Which equals 0. Okay.
Because it's 0 over 0, right?
Well, it's 0 over 0 plus 0 over h, which is 0. 0 over a little something a little bit bigger than 0. Okay. So
Wait,
therefore,
because there wasn't any x's, you didn't do any x's.
right on, yeah. Therefore, this shows that the derivative, that if f of x is equal to c, f prime of x is equal to 0. And going back to our original question here, this plus 1 disappeared. So this plus 1 in my derivative originally goes to be 0. Okay? And that's sort of neat. That means even if your line's at 100 or negative 3 billion, again, the slope is still 0 because it's horizontal, no matter where it is on here. All right.
So we just come to the last one.
Yeah. Example 2. Using, I guess spelled that right. Using Leibniz notation, dy by dx, find the derivative of y equals x squared. I'm going to get out of the way and we'll go through this. Okay, so this is the thing that gets a little bit tricky on this, okay? Remember we said on the previous page, we haven't seen dy by dx anymore. All that means is a little tiny change in y and a little tiny change in x is all that means. So the way I'm going to start this one, I'll let you guys help me with the next one. Okay, I'm going to add a very tiny amount to y, which I'm going to call dy. Okay, just a little chunk. And in the same manner, whenever I see an x, I'm going to add a little tiny chunk, which I'm going to call dx. Teresa, can you be brave, please? And foil out the right-hand side for me if you'd be so kind. Yeah, good.
And then,
Plus dx squared, but yeah.
Oh, okay. The x is kind of like a subscript of the t then.
Would that not be the like the 2x dx, and that just include the
No, because they're two different things. Dx is like a different thing there.
It's a subscript.
Yeah, think of it like that. Okay, so the next thing I'm going to put in here is if dx is equal to zeros with a lot of ones to it, if I square that, it's going to be almost nothing. Okay, so I'm going to call it 0, so it's going to cancel out. Therefore, this is going to go to y plus dy equals x squared plus 2x dx. So we'll get the idea of that. So let's say that dx was 1 over a million. 1 over a million squared would be 1 over a million. I don't know what that number is off the top of my head. So very, very small. Then we're going to say that y is equal to x squared. So dy is equal to 2x dx. It's just a different way to look at derivatives here. Okay? We'll do a few of these. Yep, no problem.
You wrote that down, didn't explain it. What does that mean?
Which part?
But y equals x squared.
Yeah, no problem.
Explain that, 'cause you just wrote it.
Well, this is where I got y equals x squared from right here.
Okay.
Right? So because y equals x squared, you can write it as over the next page. You can say that's like x squared plus dy equals x squared plus 2x dx, which is dy equals 2x dx. We'll go through a few of these and you'll see on this. Is this making sense to you at least? I didn't do it this way. You should do dy dx. You didn't do
Okay,
that.
so you're changing your y into x squared because that's your given.
Right on.
Okay.
And finally, then I'm going to divide them both by dy by dx. This is just a different way. I'll show you the quicker way to do this, though. Is this sort of looking somewhat familiar to you now, a little bit? We'll do one more like this, then we'll show you the rules here, okay? So just what I want you to remember is that x squared changed to 2x. Okay, that's what I want you to remember, because I want to show you a faster way to do things. Now, I'm going to get you guys to take you through the next example the same way. Stay with me, Haley. You can do this, okay? Have confidence in yourself. Okay? Austin, especially stay with me, because you're going to get up next. Example 3, I think of that?
Can you move it?
Yes. Okay, I'm going to give you guys the first line, and you guys can take it from there. But what I'm going to do each time is add a little chunk to the y, and I'm going to add a little chunk to the x. Okay, so you see what I'm doing there? On the y, I'm just going to add a little tiny chunk, and on the x, I'm going to add a little tiny chunk. Notice how Chris escaped right when it was his turn. You notice how he did that? That was good. Austin, can you show off your cubing skills for me, please? Yeah.
Plus x squared, 3x squared dx.
Yeah.
Plus 3x dx squared. Plus dx.
Good. Okay. Just like I said before, if dx is a very, very, very small number, like 0.00001, dx squared is going to be even smaller, so it goes to 0. Dx cubed is going to be even smaller, so it goes to 0. All right, what am I left with then if I cross those out? So if I get rid of dx squared and dx cubed, what am I left with in my equation?
2x squared, 2x cubed.
Yeah.
And plus, what is it?
Well, this is still going to stay. The dx is still going to stay. So I'm going to call that plus 6 x squared dx. Okay, now I just want to make sure this is good for people because this is a little bit different. Is everyone okay, Emma and everyone else? What just happened there? We're sort of feeling somewhat good. Just algebra is all this is, right?
What does this even help?
Well, it's a quicker way than doing this. But I'm going to show you the quickest way in the next line.
So if we did that
Yes,
to
either one of
this
them.
equation, we would,
You gonna do this? Okay.
we would get the same answer.
We'll get to the trickier things in a second.
Yeah?
Either one is okay, yeah.
No, so if we took y equals two
Yes.
x cubed and plugged it into that,
Yes.
we get the same
You
answer.
get the same
Okay.
answer. I'm gonna show you a different way because two reasons. Number one, to expand your brain, but number two, you'll have to do this way in about June. Okay, so there's another way at the end of the year, so I just want to introduce you to it. 1, 2, okay.
So, the whole like 3x dx squared,
Yeah.
that's times by 2,
Yeah.
so like, just like those x two.
Yes. Right?
So is the left side always y plus
Yes, the left side's always 1 plus 2. Now, what's our next step gonna be? What do we want to cancel now?
The y.
The y is x squared, we're saying, remember, y equals 2x cubed. Therefore, dy equals 6x squared dx, and dy by dx equals 6x squared. Okay, so let's just take a look here to summarize. To summarize what we just summarized, to summarize what we did here. Because I want to get rules for this. I don't want to have to do this, spend the rest of my life doing this long derivative way, okay? So x squared comes to 2, yeah, go ahead. The top line on the right side. So what I just did was this canceled and this canceled because it's dx squared and dx cubed. So these two things disappear. And then I just expanded back as 2 times x is 2x squared, 2 times 3 is 6. Okay? All right, 2x squared goes to 2x cubed goes to 6x squared. What happened between 2x cubed and 6x squared? What's a short form we can maybe think of this? Well, let's look at the exponents. What happened to the exponents in both of those? They're both reduced by 1, right? X squared went to x cubed went to x squared. Let's look at the coefficients. What happened to the coefficients? Exactly, okay? So this 2 comes down, 2 times 1 gives you 2, 3 times 2 gives you 6, 6x squared. So our rule is, and then I hit pause your video. I want to prove this. This is called the power rule. If f of x equals x to the n, where n is a real number, f prime of x equals nx to the n minus 1. We'll prove this one here in a second. Okay, but that's very powerful. If you look, while I'm pausing this, if you look at our warm-up, okay, 5x cubed. What we did was then 5 times 3 was 15, and then the power comes down from cubed to squared. All right, so this is actually really powerful.